Okay, let's get started. So, any questions about anything so far? Anything we covered? Any of the assignments? We're good? Okay, so we are starting with week 6. You already did selection, repetition, input, output, all that good stuff. And today we're going to talk about functions. And a few assignments that go with that. All right, so first of all, what is a function? If you've done functions in any other language, it's pretty much the same. Functions are also known as procedures. They're also known as modules. What else do we call them? We call them methods also. When we're talking about objects and stuff like that, we can also call them actions. Okay? So many words for the same thing, but it's basically just breaking your code into separate pieces that could be reused somehow. So let's say, for example, I have a C out here, just some stars, right? And L, right? So the simplest example I can think of is just there, right? We have 5 lines of code. And then later on, at some point in my program, I'm going to go and use the same 5 lines of code somewhere, right? So if I run my program, it'll show a bunch of stars. Okay, but what I would like to do is, since I'm using the same lines of code exactly twice, I would like to have a way to reuse them if I wanted to. Okay, so here's your intro to functions. What I'm going to do is I'm going to make a function called stars. So void stars, right? And this here is going to be my function prototype. Okay, this is slightly different than how we do it in other languages. Like in Python, we didn't have a prototype. You just defined a function. You could define the functions in here also, right? You can have your function definitions on top of your main. Don't do that. Okay, if I end up seeing people doing their definitions on top of the main without having a prototype, I might take some points off. Okay, and there's a reason for that. I'll tell you in a minute. So this here is basically my function prototype. Okay, and it's basically the same thing as if I was to go in there and say, well, int num, right? I'm declaring a variable called num. Here I'm kind of declaring a function called stars, right? So if you want to call it, it's like declare a function, right? So the function name is stars, okay? And functions are, you can tell something is a function because it has parentheses next to it, okay? So this is my name. The name of the function is stars. The return type, void, is the return type, and it means void means returns nothing, right? The function does not return anything. Okay. Parameters, you don't know what those are yet, but there's no parameters, none. Okay, the parameters are variables that we're going to put in between the parentheses. Like if I said int num, then my parameter will be num. Okay, but we're not doing that just yet. Okay, so this is my function prototype. I'm declaring a function which is going to have the name stars, and I'm telling the program this function is not going to return anything. That's what the void means. It returns nothing, and it does not have any parameters, right? So in fact, if you look at the main, what is the main? It's a function, okay? And it's a function that actually returns something. That's why a lot of these should end with like return 0, okay? But we kind of skip it, or I skip it. I get lazy with it because it works anyway. On some compilers, it might give you an error. So anyway, what I'm going to do is, so this is my function prototype, and underneath my main, I'm going to do my function definition. So this is my function definition, and I go void stars, basically the same thing that I have in my prototype minus the semicolon. Okay, no semicolon in my definition. And the function definition is basically implement or write or define what the function is going to do. And what is the function going to do? Well, I'm just going to grab these stars here, copy it, throw it in there. Okay? That's it. That's all it's going to do. It's going to show me some stars. Okay? Now, wherever I had these here, I'm just going to go and I'm going to take them out. I'm going to comment them out. And wherever the first one was, I'm going to call my function stars. All right? This is my function call. And then wherever that other one was, again, I'm going to call my function stars. And that's another function call. Function call. Right? So how do you call the function? You do not put void. You do not put the return type in front of it. Right? You just put the name, you put the parentheses, and you put a semicolon after it. Okay? That's my function call. And if I run this thing now, you're going to see that it really didn't change anything. I'm still showing the stars. Okay, so how does that work? So as soon as I call the function, as soon as we call the function stars, right, the program jumps to the function definition and executes everything between the curly brackets of the function. Right? So we're at line 8. We're at line. So first of all, my program works top to bottom. I'm importing some libraries so that I can use the cout and stuff. Then I'm defining my function. Then I'm going to my main. Then I'm going to encounter my function call at line 11. As soon as I get to line 11, my program is going to jump to line 32, and it's going to execute everything that's inside of the curly brackets. Okay, when it's done, when it gets to the end of the function, when it gets to line 39, it's going to go and return back to right after it was called, which is, this is your call, so right after it, and then it'll resume down, continue. There's nothing to execute because these are all comments. And the next thing that it's going to do is, try to fix my indentation. The next thing that it's going to do is continue down, get to line 22. As soon as it gets to line 22, it again jumps to 32 and executes whatever's inside my function. So every time I call my function from the main, it is going to go and jump to the function definition and execute whatever's in it. Make sense? All right. So this is a basic function which does not return. It does not return a value. Right, and it has no parameters. All right, so the next thing that I'm going to do is let's have a function that returns a value. Okay, I'm just going to call it int return, I don't know, return 1. Okay, that's it. That's my function prototype, and I'm just going to copy this stuff here so I don't have to type more. Okay, so the function name in this particular case is return 1. The int is the return type, and int means the function returns an integer. Okay, and that's it. There's no parameters. I did not put anything in between the parentheses, so no parameters. And again, this is my function prototype. Okay, so what I'm going to do is I'm going to copy this. I'm going to go back underneath my main, paste this, curly brackets, and I'm just going to say return 1, right? That's all it's going to do. So the way it's going to work now is go into this. Okay, going to here. I'm going to call return 1. Like this, right? This is my function call again. And what's going to happen is, if I run the program, you're not going to see a 1. Okay? The reason why you're not seeing the 1 is because, just like with the other calls that we had before, right? We jump to definition. So, for example, we're at line 33. We call the function. We go in here. we execute whatever's inside my curly brackets, and then return this value, right? We return this value and we replace this right here with the value that is being returned. So we're literally bringing back the 1 in there. Okay, but you're not seeing it because I don't have a cout. Okay, so shows nothing. Okay, if you want to show it, you do cout return 1, right? And let's have a look at this thing, and you should see the 1 right there on the bottom. Okay, so it brought back the 1. So I can do another one. I can say int return value is equal to return 1, right? And then I can do a cout and show you the return value. Cout return value. All right, if I run this again, you're going to see 2 1s. Okay, so one more time, what happens when I call my function here? I jump to the definition and I bring back a 1, which is basically just putting a 1 in there. Nothing, right? It doesn't do any harm. You could have a 1 in there, but nothing happens. Then I go to the next line, return 1. I jump to the function definition. I return a 1. The 1 comes back right here. And you can see the first one. That is this first one that you're seeing right here. Okay? Then I go to the next line after my function has returned and we're done with it. I go to the next line. Return value is equal to return 1. So as soon as I call my function return 1 here, we jump to the definition. We execute whatever's in it. The only thing that's in it is you're returning the value 1. So as soon as you get to the return, you exit the function here, returning 1 to the main, right? So I come back. As soon as I get to return 1, I return right where I was called, and I bring back the 1 right in here. Return value is equal to 1, then I show you return value, and that is your second one. Okay? So that's what happens when you're returning a value. Oops. Let's see. There you go. Okay, so this is my return 1. Let me call it here and here. There we go. Okay. What else? What else? Oh, okay. So if I have a message, let's say I have a cout hello world, and is this ever going to show? No. Why is that? Because it's after the return. This thing says right here, if you exit the function here and return 1 to the main, right? So as soon as you encounter a return, like in this particular case, you exit the function. It's like when you had a loop and you had a break in it, and it stops the loop and then nothing after the break happens. Same thing with the function. As soon as you encounter the return, you're out. Okay, you return back to where you were called, and this never shows, right? Never shows because it is after the return. Okay? So that's basically a function that returns a value. And you can have all kinds of fancy things in it, right? It doesn't have to be just a single return 1, which doesn't make a whole lot of sense, right? Okay, so that's a function that returns a value. Now let's have a function that shows, maybe I want to modify my function. Let's just do something simpler. So I'm going to go in there, I'm going to say, okay, void sum, and I'm going to have an int num1, int num2. Okay, and again, same deal. This is my function prototype, right? Copy all this stuff, put it under. Okay, so the function name is sum. Void again, same deal as before. Void means returns nothing. Okay, and now the parameters are num1 and num2, which are integer values. Okay, so parameters are the variables in between the parentheses of a function, right? You don't have to have 2, you can have none, you can have 1, right? In fact, let me just show. Let's just call this show num. Let's start with one parameter. Okay, so the function is called showNum. It's still a void, and it has one parameter, which is an integer value. Okay? So what are we going to do with this? I'm going to copy this from my prototype, go after my main, paste this thing, no semicolon, curly brackets, and in it I'm going to do a cout num1 and del. Okay? And so this one here was calling a function that returns value, right? So it's you have to call it slightly differently than how you call a function which shows something, maybe. Okay, so show the stars had a bunch of couts in it, so as soon as you call the function, you're going to see the couts. The return one had no cout, so if you want to see with the value that it's returning, you have to either call it from inside of a cout or make a variable equal to that function so that when it returns a value, this variable becomes equal to that value, and then you can show that variable. Okay? And this showNum is similar to the stars that we had, except in here we're showing this variable num1. Okay? So how's that going to work? This here is calling a function that has a parameter. So I go and I do showNum, and I give it some value, 10, and that's it. Okay, so as soon as I call this, and by the way, this has its own name, right? This number right here. You remember what it was called from your other programming class? What is 10 called? Starts with an A. Ends with argument. Okay, so this is the argument. Okay, and what is the argument? This is the value that we pass into the function. Okay, as soon as you call the function showNum10, right? The parameter num1 becomes equal to 10, right? So I'm sending this value 10. It is going to be received by the variable num1, and then I'm going to show you 10, right? So the argument is the value that you're passing into the function. And let's run it. And there's a 10 at the bottom. Okay, I can go in there and I can call my function showNum 1000. Right? If I run it now, my argument is 1000. As soon as I call the function here, right? This is my function call. All right? As soon as I do my function call, we send the value 1000. The num1 becomes equal to 1000. I show you the num1, which is 1000. Okay? So that's a function that has one parameter. Any questions? Okay, again, you do not call the functions using void, right? Do not call them like that. You do not put the return type when you call the thing, right? You also don't list the variables like int num1 equals to 1000 or whatever. Okay, that doesn't work. Okay, you just send the value over. That value is being received by the parameter, right? Let me put a little label on this thing so you don't forget. All right, this is the parameter, which is variable that receives the value of the argument. Okay? All right. Okay, so next thing, let's have a function that does both things. Let's have a function that, so we had one that was void, no parameters. We had one that returns a value, no parameters. We had one that was void with a parameter. Now let's have one that has both a return value and a couple of parameters. Okay, so I go, all right, int, and by the way, the return type int could be double, could be float, could be char, could be string, whatever, any of these data types, but you can only return one thing. Okay, unlike Python where you can grab a list and return a whole list, we can't do that in C++. Okay, so let's call this thing here sum. Okay, and I'm going to have, let's change it. Instead of an int, I'm going to make it a double. All right, double, and I'm going to have another double a, a, and then another double b. Okay, and then again, this is my function prototype, and I'm going to grab this thing here, and I'm going to throw it right here on top. Okay, curly brackets. So I'm going to have, I can just do this. I can say, well, let's just do an extra step. Double total, right? And then I'm going to say total is equal to a plus b. And then I'm going to say return total, right? I could have just simplified the whole thing and just said return a plus b, right? It would have been the same thing, but let me break it down into little steps for you. Okay, and by the way, breaking things down into little steps like so makes it easier for you to debug your programs. So if something's wrong, something's not working out, you can kind of break things down into little pieces and look at the individual pieces and see what's wrong versus doing the whole thing in one big step, which is okay. Right? Once it's tested and you know it works, you can simplify things. Anyway, so this is my function sum, and I'm going to say, all right, here I'm going to do something like, all right, cout enter value 1, all right, cin value 1, and I'm going to do the same thing for another value 2, all right, and why don't I declare a couple of variables, value 1, value 2, okay? So the user is going to enter these two values. Then I'm going to show you cout, I'll say value 1 plus value 2 equals, and another cout under, and I'm going to call the function, which is sum value 1 value 2. Okay, so the user enters two values. Let's say they're going to enter 10 here, and they're going to enter 20 here, right? Those two values are being sent over. Even though I'm putting a variable, right? I could put a number just like I was doing. So that is the argument. Let's do another one before I go into this. So let's say this one's show num. I'm going to say int a is equal to 100, and I can do show num a, right? So you can do a variable instead of a number. And again, this is your argument, right? This is the argument, and that's what I'm doing here. I'm sending two variables as my arguments. I'm not sending the variables themselves. I'm sending just the values of the variables. Okay. So what we're doing here is we're passing the values of the variables, right? We're not sending the variables themselves. Later on, I'll show you how you can send the variables and what the effect of that is and how you can change things. But let's look at this. So if I go in there, right, enter value 1. Value 1 is, I don't know, 10. Value 2 is 20. And 10 plus 20 is equal to 30. Okay? That's how this works. So I call my function here. This is my function call. As soon as I call my function, I'm sending two values, whatever the user enters, the 10 and the 20, into these, right? A becomes equal to 10, B is equal to 20, total is equal to 10 plus 20, return total, which is 30, and then this thing here gets replaced with 30. Okay? That's what happens. And if I give it different values, if I go 100 and 200, then it will show me different sum. All right, 100, 200, and that's 300. Okay? Any questions? Still awake? All right. So that's pretty much all I can tell you about functions. And there's some weird things that, not so weird, but let me, show you things that don't exist in other languages, or some of the things. So first of all, let's say I'm going to have a function called void, let's call it pass by value. And then this is going to be an int a, capital A, right? And I'm going to copy this thing. I'm going to go all the way at the bottom after my main. All right, and again, this here was my function definition. Now I'm going to have another function definition for this one. Okay, and the only thing that I'm going to do in here is I'm going to say, well, a is equal to 0. Okay, and what I'm going to do in here now is I am going to declare another variable, int a. Okay, and what don't you like about this one? Local variable a. Oh, I already have an a in there. Let's call it b. All right, let's call this b. Just so you see. B. Okay, so I have a variable b, and I'm going to make this variable b equal to, I don't know, 99. Okay, then I'm going to go in there, I'm going to do, okay, pass by value, and I'm going to send b over, and that's it. Okay, so what I'm going to do here is I'm going to say cout b equals b and l. Okay, and then after it, I'm going to do the same thing. Now you tell me, what is it going to show me here? When I do this cout, b equals what? 99. Okay, makes sense. What about when I go and I do this here? B equals, what is this equal to now? 0. Okay, I got you. So you think it's a 0. Let me run this thing. I'm going to have to enter some numbers here again, which I hate, but there you go. Oh, it's 99 still. So, what happens? Welcome to the C++ world. That's what happens. So, first of all, b is what kind of a variable? I mentioned this before, but this is a local variable. This is local variable b. Okay? And then guess what? The parameters are also, what do you think, what kind of variable is the parameter? So this thing here, the b. That is also a local variable. Okay, what does it mean for a variable to be local, right? Local variable is defined within a segment of your code, like a function. Let's call it within a function, right? And the examples that I had done for you was I already showed you that if you define a variable inside of an if, that variable only exists inside of that if. And if you define a variable inside of a loop, that variable only exists inside of the loop. If I try to do something like, let's say for example, quick refresher. So if I did if b is equal to whatever, 99, and then in here I have int c, right? I declare this variable here. So this is a local to the if. And if I try to do this, if I try to do cout c, that's no good because it doesn't know what the variable is, right? So can't do this. This is bad because c is local to the if above. Okay, so I cannot use it outside of the if. If I define it inside of the curly brackets, it only belongs, it can only be seen, it can only be changed and used inside of the curly brackets. All right, so that's that example, and that's basically what happens here. So if I have, so first of all, let me show you something that you can't really show in Python and you cannot really show in Java, right? So this is something very new. for all of you, unless you've taken this class before. So, or have done some C++ programming or C programming. And this is, you know, the memory addresses of variables. So what I'm going to do is, right on top of this, I'm going to do a cout. I'm going to say memory address of B is, and I'm going to do %B. Okay, that is how you pull the memory address of a variable. So if I go and I run this thing, right, there's this number right here, right? I'm just going to copy this whole thing, and paste it right here. That is the memory address of B. Okay, and by the way, that's one, you know, explanation why we want to have hexadecimal numbers, because you can see this is a pretty big number, even in hex. And if we were to use decimal numbers, we're going to have to end up using a whole lot bigger numbers, which is why we're using hexadecimal numbers. So there's millions and millions of memory addresses in your RAM. That's what this is referring to one of those. Now what I'm going to do is, I'm going to go to my pass by value, and I'm going to do a cout memory address of B in pass by value is, and I'm going to do %B. All right, and let's have a look at this thing. So I run this, and again, I got to enter some things. So this one didn't change. Right? If you look at this one is still the 357AC4. Sometimes it could change. If I introduce a lot of changes in my program, if I redeclare some other variables before and after that, it could affect where and what place in memory this variable is stored. Okay? But this other one here, the main thing is this one here has a different address. It's this right here. Okay, so the other one was this one, and the other one, this one is this. So what does that tell you? These variables are stored in different places in memory. Okay, even though they're both called the same thing, they're actually different variables. Okay, so if I go in there and let me try to open up Excel so I can show you, kind of, sort of. All right. So let's say this is, you know, I have variable name, and then you have your memory address. All right, that's my memory address, and this is the content that is stored in my memory. Okay, so I have a variable B inside my main. The variable B in the main has a memory address of this. All right, that's the memory address in the main. This is B in main. Okay, and then we're going to have a B, which is in what I call it, pass by value. Okay, and this thing has a different memory address, which is this right here. Okay, and then the content of these, this original one, I said B is equal to 99 right here, right? So I go in there and I say, okay, this is equal to 99. Then we go and I show you the memory address. Great, I show you this. It's a 99. Then I jump to pass by value, right? I call the function. This is my call. Right? Then I jump to the function body. Right? This is my function body. Anything between the curly brackets. And then I'm changing variable B to be equal to 0. So I go in there and I make this thing equal to 0, which is fine, right? I can do that, no problem. But it's a different thing, right? So this is one variable. This is a different variable. They're both called the same. They're both B's, but they have different addresses in memory. So changing this has no effect on this. Okay? Just like if I was to change this, and this was 99, then this doesn't change. Okay? So changing one does not affect the other. And that's what happens. That's what we're doing with pass by value. Okay? So this was the 0, this was the 99. Okay? Does that make sense? Any questions? Okay. So, and this is one of the, more advanced features of C and C++, and that's why they call this kind of like a mid-level language, because you can actually go all the way at the hardware level and you can move things around memory just like you could with assembly language, which if you're a computer science major, you will have to take, and I teach it. So if you want to have access to the hardware, you can do it with assembly, but you can also do it with C and C++. You can't do it with Java, you can't do it with Python. Python and Java are too high level. They don't have pointers. There's no real way for you to do these kind of things in those higher level languages. Okay, they're easier to write. The code for Python and Java a lot of times they're easier to write than C++. Less things can go wrong because of the fact that we have abstracted ourselves from the hardware level. But if you really want to tweak things the way that you want, that you might want to, it's not possible unless you're doing it, all the way at the hardware level with C or C++. So anyway, this is just your, first little baby steps with pointers, okay? And once you do I'm going to introduce more things about pointers later on in later classes. I'm going to show you how this is passed by value. We can also pass by pointer, we can pass by reference. There's two different ways we can do these, or many different ways we can do this in C++. There are ways where if I wanted to, I could change the value from the main, the value of B in the main from another function. Okay? But I'm not going to do that today. Okay? So, now you know. So, arguments. What are arguments? Arguments are the values that we send or pass into the function. You can send a number, you can send a variable, but even if you're using an argument variable, you're not sending the variable itself, you're sending just the value of that variable. Okay, so whether I put A or I put 100, it doesn't know any difference, right? It makes no difference for it. Okay? If I have a variable declared in my main and I pass it over into a function and that function does something, even though that variable is called the same thing, it's not going to affect the value of the variable in the main. Okay, so this one here is no change. All right, does not change. All right, this here does not change the value of B in the main. Okay, so that was the moral of this story. So again, you have your function prototype. Function prototypes go on top of the main, right? And I guess it's a good time for me to tell you why. All right. So the reason I would like, or not would like, but I require you to have your, if I can type it, prototype. There. The reason that I want you to have your prototypes on top of your main is because if you have that and then you have your definitions underneath the main, the order in which you call these functions does not matter. So what can happen is you can have one function calling another function, right? So let's do this. I'm going to say void function A, and this one's going to have num, and then I'm going to have a void function B, which is going to have a function, well, let's just leave it like that for now. I'm not sure where I'm going with this, but let's see what happens. Okay, so these are my two function definitions. Function B. So function B is going to call function A. So it's going to go this. So I'm going to do this. Cout num equals num, maybe an endl. And then in function B, I'm going to go and call my function A. And my function A, I'm going to send it a value of like 1, 2, 3. Okay? And then to start this whole thing going, I am going to go in here, I'm going to call function B. Right? That's my call again. Function call. Okay? So what happens? As soon as I call function B, I am going to jump to the definition of function B, which is lines 96 through 99. At line 98, this function calls another function, which is the function A. We're going to jump from line 98, we're going to jump to line 92. We're going to send the value 123 into this thing, then we're going to show you the value of 123. So when I call this, the end result is I'm going to show this result. Right? So you have one function calling another function, and you can see the num is equal to 123 all the way at the bottom. Okay? So the reason why you want to have your prototypes on top is because you don't want to worry about the order in which these functions are defined. Right? So for example, in this particular case, it would have worked even if I didn't have prototypes, right? But if I was to grab this here, cut it, and put it on top, like that. If my prototype did not exist, right? If I did not bother to write my prototypes here, right? Then you could do this without the prototypes. But what's going to happen is, as soon as it gets to this line, it will tell you, I don't know what function A is. Because function A is defined underneath. Remember, program works top to bottom, right? It goes through function B, then it goes to try to call function A, and it doesn't know what function A is because maybe I got rid of my prototypes here, right? I got rid of them. So it doesn't know what function A is. And that is going to create a bunch of mess here. See what's happening? Right here, first of all, right here it's telling me undeclared function B. Why is that? Because it doesn't know about function B, right? I didn't have a prototype. I could grab my definitions. I could grab my definitions here, cut them, and throw them on top of the main, just like I have been doing in Python, right? Then that's going to fix this error here. Function B is okay because as we're going through the program, function B has already been defined before the main, top to bottom. But as soon as I get to this, now it doesn't know what function A is. Why is that? Because it's defined after it. Okay, so to prevent this kind of an issue is the reason why I require prototypes from you. Okay, so put your prototypes on top of the main, and then you can define these things in whatever order you want on the bottom. It doesn't matter. You don't have to worry about, oh, hold on, I have to move this on top of the other one because they don't know about each other. Okay, that's why we want prototypes. And that's how we do functions in C++. Prototypes on top, right? What's the prototype? Again, you're basically declaring what kind of a function name we're going to use, what's going to be the return type, if the function has any parameters, right? So the return can be void. Void means it returns nothing. It could be an int, it could be double, it could be character, right? Different things the function can return. The function can have parameters, right, which are the variables that accept the values that we pass into the function when we call it. You can have multiple parameters, right? As soon as you hit the return, all right, if there's ever a return, what was that example that I had, right? So there's a return right here. If you have something after it, you're never going to see it because it's just like having a break in a loop. Nothing after the break shows. What else do I want to tell you? There was something else, but I'm forgetting it. So maybe we'll come back. So, all right. So the next thing I'm going to do is, let me just go through these real quick. So I have some links in here on what a function is. This example stuff, I have it in there. Return. There's a return example with a function. Some more explanations on what's what. I have a video in there, a couple of videos on the different kinds of return, different kinds of functions. So the 3 different functions, each has a video. Variables, local, global, parameter, scope. And in here, I have a couple of, just like different examples of what is a local variable and a global variable. So let me save this one so you can see it. If it shows. it's not showing. No. Not that. Ah, what the hell? Let me just zoom in on this thing. So there you go. All right. So the purpose of this exercise is to show you what a global variable is. And by the way, you don't get to use global variables. Okay? If I see you doing global variables, I might take points off. Okay? Unless it's like you're trying to make some kind of a constant like pi or something. And the reason for that is because if you start using global variables, you can pretty much not have to learn about parameters. So maybe parameters are confusing and you want to just have all your variables in one place all the way on top of the main so that everything can have access to them. So anyway, this is a global variable, and I guess why don't I just go to my code and just show you. All right, so if I have, let's say in here I'm all the way on top right here. I'm going to say int c, all right? And we say that this is a local variable, right? So this means that the variable c belongs to the main. Only the main knows about the c. Okay, if I go into my other functions, let's say here, and I say, okay, well, c out, c equals c. That's not gonna like. It's not gonna like it because if I run the program, use of undeclared identifier c. That's the error. Okay, and the reason is that I can't do this, right? So I can't do this. This here is bad because c is declared in the main. Okay. But if I went and I declared all the way on top, right? I'm going to go all the way at the top of my program, like say, I don't know, right here, int d. Okay, now this is an example of a global variable, right? Don't use these. Don't use global variables at all. And the reason for that is normally in the real world, you're not going to have a program that's 100 lines long. You're going to have a program that's going to be tens of thousands, if not hundreds of thousands of lines, if not millions of lines of code. And there's going to be teams of people that are working on these. Each team possibly could be working on their own function, right? You don't want your team to go and mess up the data from somebody else's work, right? So for example, let's say D here is whatever, right? Some information is stored into D. I can go and I can say D is equal to 10 here. That's fine, no problem. I can go and in some other function I can say C out D equals D and L. Alright, that's okay too. So D is a global variable, can be accessed. So global variable can be accessed and changed from any place in the program. And by any place, I mean any place / function. Okay, so anywhere in my program can accidentally, any of these teams can accidentally mess up the other team's data, right? So the idea in object-oriented programming and just in generally in programming is this modular decomposition. So you get the big problem, you break it down into little sub-problems, you spread the different problems across multiple teams and multiple people. They work on these independently, they put them together at some point, but as soon as they put them together, you don't want to have, parts, common parts that can be accidentally messed up by the different teams. And that's why you do not want to have global variables most of the time. There might be a need for it, maybe if you want to use like some kind of a constant like pi or something. It makes sense to have a global variable pi so you don't have to define it for everybody. That kind of stuff. Okay? So do not use global variables. Okay? The only kinds of variables you're going to be using are local variables, parameters or local variables, right? So this variable num belongs only to the show num function. These two variables, the a and the b, they belong only to the sum function, right? This variable c belongs only to the main. So only local variables, and then I'll show you how you can change variables from one place to another place, right? Let's say if I wanted to have a variable that's in the main, but I want to have the user type in the input for that variable from some other function. I'll show you how to do that. Okay, but this is the main stuff that I wanted to tell you about functions, and there's more, and I'll show you those later. So the next thing is, so these are your variables and scopes and stuff. I have a bunch of examples in there for you to see. And you're probably going to have to type it up, because that's how I do things. And yeah, there you go. You're going to have to type these two things that I just showed you. Make sure you type all the comments, right? I don't just type them for myself. I type them so that you can learn what's what. And you're going to learn better if you just type them up yourself than reading it. Okay, so make sure you type up all the comments. Everything that you see in there is important. Type it up, and then test your program, show it runs, and submit all that good stuff as usual. So that's the first one. 34. 34B is type the sample program below. That's nice. I don't have a sample program below. Somebody submitted it though. How the hell did you do that?
What happened was the first March 34.1,
Uh-huh.
there was no submit on that one, so I assumed that,
Oh, yeah, that's you, Oliver?
yes.
Okay, cool. You did the impossible. Let me try. Yeah, so their call function from the main, not the main. That's lame. I have it somewhere. Damn it. Yeah, so what I'm going to do is I'm going to update this. I have it. Let me do this. I'll blame this on Canvas also. I hate Canvas. What the hell? Now he's showing up? What? Well, I don't know how that happened, but this is the one that I'm going for. I don't know how Moodle pulled the right picture that I'm looking for. That's the weirdest thing. Okay, but this is the program you're supposed to type up, right? So you have, write the main to produce the output. Oh, no, wait, it showed up. It's Canvas, people. It just took forever to show up. Wait, no, that's 34. Okay, damn it. 34B. No, it's there. Now it's there. Just Canvas had to take forever to show the picture. There's the picture. So what I do is, baby steps. First one was type up the example, get it to work. Now I'm giving you the function prototype. I'm giving you the function definition. You got to write the main and call the function to produce the output that you're seeing on the bottom. Right? So that means that make sure that you enter the, for 5 people and all that good stuff. And each person weighs 180.55, and then you show the whole weight for all these different people. Okay? So there you go. That's the first one. The next one, 35. Write the definition of a function that does not return a value and has no parameters. So the function shows a random number between -10 to 10. So remember how you make a random number? Well, same kind of deal, but now we're going to put it inside of a function, and that function is only going to return a negative value, a random number between -10 to 10. Okay? So what you have to do is, I actually show you how to write, this is supposed to be your main, right? This is how you're supposed to call the function from the main. This one here was an example of how to make a random number, and then you're supposed to write I give you the prototype, you're supposed to write the definition. So this is your prototype, this is your main, and then this is what it's supposed to look like when you run it. Any questions? The same stuff that I was showing you with functions. Now you get to practice it. There's another one here now. Write the definition of a function that returns a float and has two float parameters. Okay, and by the way, this is the kind of stuff that you need to know for the midterm, because one of the parts on the midterm is going to be things like, all right, write the function that has an integer parameter or something that returns or whatever. Okay, so if you don't know what a parameter is, if you don't know what an argument is, if you don't know what a call is, what a function definition is, you're going to be lost. You're not going to know what to do. So you got to know the terminology. You got to know what I'm telling you to do. Okay, so this here is, you have a function. This is your prototype, right? I give you the main. This is what you're supposed to call it, right? You can literally copy paste these and it should work, but you have to write the definition, right? So in this particular case, you got to write the definition for the larger, right? So why don't I just give you a tiny little hint here. So this is number 36. All right. So I'm going to have a function. This one is larger. I'm going to throw it right on the bottom. Okay, so this is going to be a float larger. Is it larger? No, smaller. Okay, and I'm going to have an int n1 int, or make them floats. Float n1, float n2. All right, that's my definition. I mean prototype. Copy this. Put it at the bottom. Curly brackets. You can have an if in there. So if n1 is less than n2, you return n2. And otherwise, you can just say return n1, right? Because if it wasn't this one, then it's got to be the other one. Okay, you can add another if. Now, if n2 is less than n1, right, then return this one. But a lot of times, compilers are going to get picky, so it will kind of say things like, well, what if this isn't true and then this isn't true? Then what is this thing supposed to return? And for that case, you should have like a return, right? If it's not one or the other, return, I guess, one of them. Something like that. Okay, so basically this is your default return. Default return. So if all these other, if the two ifs are not true, you don't get to return anything. So your default return is what happens at the end when all the magic is done. Okay, so there you go. That's your smaller. And the way I would do it is I would just do this. I would just say return n1, because if it isn't n2 that's the smaller, well, actually, smaller should be n1. Nobody's correcting me. n2. There you go. So if n1 is smaller, you return n1. Otherwise, return n2. That's your default. Default return. Happens when the ifs are false. Okay? All right. So that's that. The next one, 37. Write and test the following function that returns the average of 4 parameters that are passed to it. So you have a float, that's what it's going to return. You have a couple of variables in there, right? You have val A, val B, val C, and that's it. Write and test the following function that returns the average of 4. So now I'm not giving you the main. I held your hand long enough. Now you gotta, do your own baby steps, right? So you got to write the main, you got to write the definition, call the function from the main, show the results. Okay? So that's what you have to do for this one. Any questions? Anyone want hints on this? Average of 4 numbers? Really? Come on, Rigo. Speak up. I'm looking at you. Do you want a hint?
Yeah, sure.
Okay, all right. Let's do average of 2 numbers. So I have float average, and I'm going to have 2 numbers, float n1, float n2. All right, grab this thing. I should have put a label in there. So this was your hint for P, I can't remember what hint. Is it 36? All right, that's 36. And then here, I'm going to do, and maybe I should have called it cout smaller number is smaller, and then put it like a 1, 2, right? And by the way, when you're testing these, make sure you test them both ways, right? So for smaller, if the first one is smaller, test it this way, then twist it around, make this the smaller number. If it works both ways, program works, right? This is your P36 hint. P36 hint. And this is P37. P37 hint. All right. Paste. Whoops. Average. Average goes there. So this is your P37. All right. You get two numbers. All right. And you're just going to return. Let's just do float average, right? And then you can say average is equal to n1 plus n2 divided by 2, right? Return average. You can spell it, right? And then you call this thing cout the average is, and then you might want to show the numbers, but whatever. Average 10, 20. All right. So that's that. All right, and then maybe you want to grab this thing and then twist it around so you see that the average works both ways, 20 and 10. And there you go. So, you know, another hint is whenever you're testing your programs, choose small numbers, right? It's much easier for me to do the average of 2 plus 4 in my head than it is if I pick some crazy big number and then I have to plug it in a calculator or something. So get into the habit of making your life easier. Just test it with easy numbers. Okay, so that's 37. Is there more? All right, that's it. So then there's like a loops and conditions quiz, which is basically kind of practice with.
There is one more assignment.
38. Okay, I must have put them in a weird order. 38. Okay. This one is a function that's going to return bool. All right. What was bool? True or false. Right? And it goes like this. The function is called cigar party. There's cigars in there, and there's also weekend. And yes, it's the same thing you did in the Python class, but in C++ now. So basically, apparently, when squirrels get together, they like to have, damn it, acorns. I changed it to acorns because it makes more sense. It used to be cigars. Okay, a squirrel party is successful when the number of acorns is between 40 and 60. Let's just call it acorns. All right, acorns. All right, and that's what that is going to be. Acorns, 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 and more acorns. Okay, so the way it works is you have to check to see if something is a weekend, right? And if there are, okay, so if it is a weekend, normally it's a successful party if they gathered between 40 to 60 acorns, right? If it's less than 40, it's not a successful party. If it's more than 60, it's not a successful party. Don't ask why. Okay? But if it is a weekend, there's no upper limit, which means that it is a successful party as long as it's more than 40. Does that make sense? No? Yes? We're good? Anyone want hints on this? Rigo's not even looking at me anymore. Okay. Let me just give you another example here. So this is P38 hint. P38 hint. Let's do the sleep in thing. Although that might show up somewhere. Whatever. So P38 hint. Okay, so I'm going to have a function which is going to be... in fact, why don't I Give me 1 second. Let me go to coding bat. Let me steal some of these from Java. Java logic, caught speeding. There you go. All right, so let's do this one here. You're driving a little too fast and the police officer stops you. Write code to compute results encoded as an int. No, I don't want an int. Hold on. I want something that returns true or 6. Alarm clock. Given a day of week encoded. No, that's a string. We don't want a string. No. Damn it. All right, I'm going to make up my own, just like I was going to. So it goes like this. So we're going to have a function bool sleep in, right? And this thing is going to take a time and another parameter, which is bool is weekend. All right? So the way it goes is this. So the sleep in, so you can sleep in if, or keep sleeping. All right, sleep. I'll just call it sleep. You can sleep if the time is less than, we'll go with the military format, and you get to sleep until 9. Okay? There you go. So you can sleep if the time is less than 9, right? Or if it is a weekend, okay? And the function returns true. The function returns true if you can sleep. True, false, true if you can sleep, and false otherwise. Okay? So I'm going to grab this thing, I'm going to copy it, write my definition right there, get rid of the semicolon, curly brackets, grab this thing, throw it here. Okay, so I guess if it is a weekend, if is weekend is equals to true, right? Then you can return true. There you go, right? And by the way, this here, we can simplify it. Instead of doing it this way, I can also do if is weekend. Since is weekend is a Boolean, I don't have to say if it's equal to true. It's either going to be true or not. So I don't have to say the equal equals true. It works just like this. Okay, so if it's a weekend, you get to sleep. Otherwise, if your time is less than or equal to, let's just go with less than 900, right? We're going to go with an integer. Maybe you should change that to a double, whatever. We'll leave it as an integer. If the time is less than 900, it returns true. You can keep sleeping. And if it's not either one, then I'm just going to say return false. Okay? So it's not a weekend. It's not less than 900, so you don't get to sleep. Okay? So if I wanted to call this thing, I should call it a couple of times. Cout, right? This one is weekend. And I'm going to do sleep. And I'm going to give it whatever time, 2300. And then this one is going to be true. All right, and that'll be my first test. This one here now is going to be time is less than 900. All right, so time is 900 here. It doesn't have to be a weekend. That's going to be a false. That'll be my second test. And then I'll do another one. All right, this time the time is whatever. Let's go with time is 10. And this is false also. All right, so this one here should give me a 1 because you can get to you get to sleep. This one should give me a 1 because you get to sleep, and this one should give me a 0 because you don't get to sleep, right? And that's your hint for 38. Any questions? All right, I'm all hinted out. That's all there is. P38, and then after P38 there is a little quiz for loops and conditions. I've set these to unlimited attempts, so if you don't like your score the first time, take it again and again and again until you're happy. Okay? We're good?
Some clarification.
What's up?
On the acorn.
Yep.
So it's successful if the acorns are between, during the weekdays, if the acorns are between 40 and 60.
Yeah.
And if it's outside of that, it's not successful.
Yes.
More than 6, it's safe.
Yes. So if you have okay, so basically it's a weekday, it's Monday through Friday, and the only way for this to be a successful party is if you have a number of acorns between 40 and 60. Right?
All right. And
Now,
then
if
the
it
weekend, you can have 40 to anything.
anything.
Okay.
Yes, so if it is a weekend, if it's a Saturday or Sunday, there's no upper limit. So anything over 40 is a successful party.
Okay.
Okay? And that's it. So, as you can see, these start piling up, and if you're not keeping up, you are not going to be happy very soon. Okay, so we're already on 38. I remember I sent you an email that you're supposed to be putting in like 6-7 hours worth of work in this class, especially if it's your first programming class. If you took another programming class already, you should be able to do these faster. But if it's your first programming class, you got to put in the time. And if you don't put in the time, we're at what, week 6? 5 times 7, you're 35 hours behind, maybe. You know, worst case scenario. So got to keep up with these. Treat it like a math class, and you're going to be very happy at the end. Okay, that's all I have. Thanks for coming. I'm going to change this thing to a string. Lowercase string, because it's supposed to return a string. String acorns. Yeah. Okay, that's all I have for today. I finished earlier for once. Okay? So if you need help, come see me in my office hours. Send me your emails. You know the drill.